Good morning, grade 10. This is Mrs. Pascale. This is a correction of the Monday homework on the Pythagorean theorem, chapter 10, section 10.1. In the first exercise, we need to determine whether the lengths can be side lengths of a right triangle. In order to do that, we need to use a converse of Pythagorean theorem that states that when c square is equal to a square plus b square, we can have a right triangle. So in number 23, 15, 36, and 39 speed, start by the highest length, 39 square, it's equal to 1521. 15 square and 36 square gives 1521. Since we have the identity 39 square is equal to 15 square plus 36 square, then we can say that they are the three sides of a right triangle. In number 24, 12 meter, 60 meter, and 61 meter, 61 square is different from 12 square plus 60 square, so we can deduce that the three sides are not side lengths in a right triangle. In number 25, we have 13, 35, and 38 inches. So 38 square is different from 13 square plus 35 square. So the three sides are not side lengths in a right triangle. In number 26, 16 centimeter, 63, and 65 centimeter. Since 65 square is equal to 16 square plus 63 square, so the three sides represent the side lengths in a right triangle. In number 27, 14, 48, and 50 inches, 50 square is equal to 14 square plus 48 square. So using the converse of Pythagorean theorem, we can say that the three sides represent the side lengths in a right triangle. In number 28, 16 yard, 30 yard, and 34 yards. Again, 34 square is equal to 30 square plus 16 square. So using the converse of Pythagorean theorem, we can say that the three sides represent the side lengths in a right triangle. In number 29, we need to find the distance between the swimmer's head and the lifeguard head. As shown in the figure, to calculate the distance between the two heads, we need to find the hypotenuse of the right triangle formed in the figure between 8 feet, the dotted line, and the distance between the two heads. So to find the distance between the two heads, we need first to define the length A, which is represented by the dotted line. A is equal to the 11 feet minus 5 feet, so it's equal to 6 feet. Now we can calculate the distance or the length between the distance between the two heads represented by the hypotenuse of the right triangle. So using the Pythagorean theorem, c square is equal to a square plus b square. So c square is equal to 100. Hence, the distance between the two heads is equal to 10 feet. In example 3, we need to determine whether each set of numbers is a Pythagorean triplet. Any three sides forming a right triangle are called Pythagorean triplet. So in this question, we need also to determine whether we can use the converse of Pythagorean theorem to deduce that the triangle is right. So in number 30, since 61 square is equal to 60 square plus 11 square, the three sides represent a Pythagorean triplet. 85 square is equal to 84 square plus 13 square. So yes, it's a Pythagorean triplet. And 32, since 58 square is different from 41 square plus 40 square, so it's not. In 33, we have 130 square is equal to 120 square plus 50 square, so yes, it's a Pythagorean triplet. 34, 130 square is equal to 32 square plus 126 square, so yes, it's a Pythagorean triplet. And 35, 53 square is equal to 45 square plus 28 square, so yes, the three sides represent the side lengths in a right triangle and they form a Pythagorean triplet.